This meeting is being recorded.
Assalamu alaikum. I am Ahmed Mahdoub.
مصعب صادق.
And now we are here for exercise 4 in PT2. So let's dive in.
شير سكرين.
Share screen first. Okay. This is question.
Adopting concept of composition. So we put the class in the class. Okay. Polynomial is an function. One, two, or more variables.
Polynomial function like 5x squared minus 2x plus 7. It's a polynomial like consisting of 3 terms.
Coefficient per exponent. Okay.
Here will be just in this, we're just doing single variable polynomial, not like 5x squared. If it have x and y, it would be a trouble. So single variable will be easier.
And single variable polynomial can be modeled with two classes. So is the polynomial
So it's the first class term
term.
and the second class polynomial relation 0 to 1 to many.
Okay.
This is methods.
The attributes for terms coefficient.
This is exponents.
Okay.
Constructor I think is given. Set to set the attribute, the commutator function.
Coefficient return terms attribute coefficient exponent. Evaluate the terms. X equals to then the term. Evaluate 5. Square.
Essentially evaluate like 1 negative 4. Should use power.
Okay.
C math. This is the requirements for the code to implement the class term. So we should write a complete definition. The class attributes in the constructor has been given the program complete. Okay. So we just like define the methods, the given methods, the set and evaluate.
So this is the output. Okay.
Second is the implementation of polynomial class. The main function, creating an object, and that's it. And evaluating a polynomial with different values from 0 to 5. So the output should be,
So you should make an array of polynomials.
yeah, array of terms.
Okay.
Array of terms inside polynomial. I think it would be the best representation. And the output should be something like that. Okay. So start. Yes, let's start.
Okay, this is the code.
Let's add the names first. Almost done most of it.
MSI.
It's fine. Today is 19 December. Started at, I think, at 2.
Yeah.
English you will know later. It's the first session.
Okay.
So this is a class term, two private numbers, coef and except coef for the coefficient. except for the exponent. The constructor is given. A set function, the evaluate function, exponent, and the coefficient.
No private number.
Yes, it's a polynomial. I think we should create the private in the composition. We can just like add maybe an array of terms inside the public and maybe enter the input by the user. Input number of terms in the private.
Okay.
So we can now I think
Oh, here.
here the
I
public,
say here private.
number of terms. And you can add array of terms as a
So make a composition of
yes. It can be either private or public.
terms.
Oh, terms.
Let's make it small.
Yes, maybe.
I said array.
Size, yeah. Like a size like 10 or something like that. Maybe 10. 10 is enough.
Okay.
Enough terms.
So it's good.
I don't think there's a need for the parentheses. It's like this. So I think it's now a public function. We'll figure out later. Yes.
Yes.
So we should dive in the implementation of the class term. Firstly, I think under that maybe before the main.
It's written down.
Should write it before the.
Yes,
Oh,
of course. I mean, just here, yes.
No, I don't think it makes difference.
You implement me or you?
So maybe I can implement the first two and we can navigate. First function is setter function. think here should put the scope resolution. So setter function is just a mutator function. I think just to
Coefficient is
just to equalize
yes. So coefficient equals to C, for example.
and also same for the
This one.
exponent.
This just to reach the
This is just
private numbers.
yes, just to set the values.
Okay.
I think it's like this. Yeah, the attributes over sets term attributes coif and except respectively. So I think just like this. So the second machine they evaluate. Actually, I think this now check what the values of the
Scope resolution.
let's write it. So they evaluates the term with the values of x. For example, if x is equal to 2, then the term 5x squared it evaluates 5, 2. Oh. So it would be like the usage of the input later plus polynomial would be calling the evaluate. But for now, it will just be I think only one mathematical
Yes, only one.
function.
So just evaluate for only, like, for example, 5x squared. Just evaluate this one.
Yeah. So this is the coefficient, and coefficient will be multiplied by this variable to its power.
Okay.
This variable is x here. So it will be like just say 5. Can return this. I think
By the exponent,
power it's
x to exponent.
it's so you can just return it like without equal.
So just return this.
Yeah. I think just returning this equal like
Okay.
this. Let me check if this. Yeah. Just here the coefficient is multiplied by this by the
The
variable.
variable is, to the exponent.
It will be called later, I think, in the input here.
That's still is terms. Okay.
Yes.
What do you have it? Integer exponent.
And the coefficient.
So I think we just return these two.
Yeah, just returning the exponent and the coefficient.
Okay. But wait. Okay. Then exponent here, right?
Yes, it's that's thing.
Ah.
Then it's the value exponent.
And
The other term, I think, is the value of the coefficient.
x for exponent. Exponent, right?
It's here also should be x.
All right.
Yeah, it's also mistaken. Let's check the private functions to see what's written.
Yes. Here, the coefficient. This one also. I think we return also.
Yes, this returning the coefficient.
Anything more? So I think we are done with this first one.
So yes, this is a very requirement here in the just implementing the class term.
Class attributes and constructors. Okay.
This thing. So I think these are the 4 methods of this class. And, okay. Now go to implementation of class.
Class what to
The polynomial.
okay. So first the constructor. Why did you delete that?
So first of all, the constructor, yes. The polynomial.
Polynomial.
Scope of function, not polynomial.
Okay. The
Here should be
packets.
Yes.
Non-terms.
Terms.
Non-terms.
Term. Term or not terms?
Terms. Terms. Okay.
Let's see.
It is. Just like this is the constructor.
So I think this is the
Constructor.
constructor is like this.
Now you see the test. Okay, then void input.
Okay. I can do it. Can navigate.
Do you want to do this?
Okay. So let's start. Firstly,
We just gonna go up.
here.
Up, no, not here. Up here. Let's see. This is for
Yes, import is add list of terms for polynomial using user input. User needs to enter the coefficient and the exponent of each for each term. So this is just like the user will enter the exponent and the coefficient for each term.
yes.
So firstly, it will
Should enter this.
be seen, see how this, and then he will enter. Firstly here, poly.
No, no.
Scope summation operator.
Delete the this.
Here,
See out. Take end line. And over what?
up.
Not yet. How many terms? I think we should also.
Yeah, so also see how this.
Let's see. See out, and I think we should make a space. You notice that?
Oh yes, yes. Here in the output.
Yes.
This
I think we can just add a T/T.
slash C or set with, or maybe the slash is okay. I don't know. Here we put
Slash not this.
backslash. I think.
Yes.
Backslash how many times? Like this.
Volume. And the user will input, right?
Yes, and these will input the number of terms. So here it will
Okay.
be
See.
seen. Seen no terms. There is no terms. Okay. So here the user just enter the number of terms.
Yeah.
Here he should enter.
This should be in for loop.
Yes, because
Because if we have more than one term, it will.
yes, it can evaluate as 10 terms or 11. So for
T, right?
equal to 0.
It's just terms.
plus. Then inside the for loop, the user will enter. I think here we should define firstly
I think we should say all this
Yes, should see all this.
forms. For B pi plus 1 coefficient and its 1. It should be in
Yes, right. Rotation.
coefficient and x, right?
Yes.
Then Cn.
But you should, I think, let me just a second. Should first here define two. First
Define here or outside?
here.
Inside.
What be the difference? Two values that the user can enter.
Exponent and coefficient.
Yeah, maybe C or
Anything else. C. I think C is enough because this will take so much time.
just copy it. Just for the readability of the code. It's coefficient and exponent.
Yeah.
So the user should enter these two values.
Yeah.
So then after the user enter these values, I think we should pass it to the set function in terms to set these two values as coef and x in the private numbers. So these values will be passed.
We will call the set function here.
Yeah, called single solution and call to terms and I since we make it
for the object we have called. Okay, I got it. I think like okay.
Here, for example.
Terms I, the object we created, right?
Yes.
Terms I dot set, right?
Yes.
Dot set. We get these two.
Yes.
So 1 x 1, right? Like this, right?
Yeah, I think like this.
We call this we call the function.
Yes.
So what's next?
I think that's it. It's like the user input and we pass the values to the coefficient and the exponent.
Okay, good.
It's all about
Input.
Yes.
So what's next? What's the next?
So back to
Evaluate.
evaluate. Yeah. Array of terms.
Do you think we should put this here or in the private?
Doesn't make a difference. We can check it later. See if the difference between putting it in public and private. Don't think it can make any difference. So we finish with input. Proceeding with evaluate.
Here. Binomial.
Okay. So in this, I think let's just check. It's required the evaluate. Evaluates the polynomial by summing up all the terms based on the value of x. For example, if x is equal to 2, then the polynomial will be 5x squared minus 2x plus 7. Evaluate to 23. So the value of x here should sum all the terms.
So I think we should define a sum. for this?
Yes.
Can we
Here.
define a sum? Equals 0, for example. Okay. Um, so doing all the terms based on the value of x. So all the terms. So if you have more than one polynomial, we should. I think we should make a for loop for this,
Yes.
for all of this. What do you think?
All the terms. Yeah, I think it's only be solved by copy.
I think it should. It
Copy.
should be like this size.
Yeah, exactly.
Here, Control B. Okay. So
So the sum all up the terms.
all the terms.
So I think we call the evaluate function in the terms. Like it will be terms sum is equal to
Sum is equal to
sum plus
terms dot.
terms I
Yes.
dot evaluate. So
But here we are defining evaluate function.
yeah, here evaluate inside polynomial. Calling to evaluate inside terms.
Ah, yes, I
So
understand.
should pass the value of
X.
value of
This
so
X here.
well, maybe you can like here also for the deliverability of the code you can just make it like this.
Plus equal, no?
Yes.
Okay.
So I dot evaluate and then it will return the sum.
Return the sum. Can
So this is this check. Okay, that's input. The list of polynomial using this input, and this is about evaluate.
okay. Let me check what is also next here.
And the coding.
Okay, in the polynomial we have the largest term and the degree. I think we should define also these two methods.
Yeah.
So here. In term polynomial.
It's complicated.
Yeah.
This will return the largest term. So it will return a term class. Term or
Yes, you have to define one object called term, for example, largest equals terms.
I think here is assume. Like assume the largest is terms, for example, terms 0 or terms.
Yes. The initial value. So you're just initiating the value. So to define the largest term, it's just like normal numbers. You make a loop and then
Same like
after this one, yes. I think we can use this.
this loop. Yeah, maybe. Same loop.
For C. For B. Okay. So then we compare between. So in the polynomial, to know if which one is the largest, I think we just compare the exponents. So we just compare the exponents of this one and this one. I mean,
Like if you mean x cube is bigger than x square, something like this.
yes.
The largest term. Oh yeah. By,
Yes.
by degree, I mean.
Of terms I.
So you're going just to compare the exponent.
Yes.
Okay.
This one is larger than the largest dot exponent.
Oh.
Then we
And then you're going to assign the value of largest.
exactly. So the largest will equal times I. Times I. This is the loop, okay? Then I think we just return the largest. Return largest. Okay.
Yeah, let's check what's said about largest here in the slides. Yeah, I don't think it's something said about it.
I think
Go
yes.
down to see.
Implement or record the tree. So I think you just, because it's a method, we should define it
So we just define it, but I don't think it would be like required in
in the code.
input.
Okay, what method also you need to define? Degree.
I think just degree left. Also, I
Degree.
don't think it's also mentioned in the code will be used.
Degree. I think he just want the degree of the polynomial, you know, like this. Polynomial degree. I think we should just
Oh, you want just like the degree to get the degree of the largest.
of the largest term.
Yes, maybe because the degree, of course, like if you have a polynomial expression,
The degree of the yes.
the degree would be the degree
I
of the
don't
last,
think
largest
I
term.
don't think this should be. It is after largest term.
Yeah, it's after the last term.
Yes, I got it. The degree of the polynomial is the degree of the largest term.
Yes.
So I think we should define a term largest equals this function. We call this
Oh, you don't call the SS. So here the largest term, largest class will be
this
equal
one.
to largest here.
So then we just return the exponent of this one.
Yeah.
Largest dot exponent is anything else?
Don't think so.
I think this is the method, right? Okay.
It's all about polynomial.
Okay.
Just a second. So this is implementation of terms. This is implementation of uh polynomial input. So users to input the coefficient, the exponent, and then to input the number of terms required, evaluate to sum up all the term largest, return the largest term, so we can use it in degree so that we can get the degree of the
Polynomial.
the whole the polynomial expression.
Okay, then I think
Pick here up. Nothing. Okay. So now go and proceed with main. I think the last thing is this is the second requirement, the implementation of polynomial. This is the first. Done with 1 and 2. Now we're going to proceed with main.
what do we have to do in the main function?
Main function. Okay. Firstly, in the main function,
Create a polynomial object.
add terms polynomial using user input. So there's two things we should do. Two lines to sustain it. Firstly, create polynomial object. Okay, let's create a polynomial object. Name it, for example,
P.
poly or P, maybe P.
Polynomial P. Yes. Okay.
Secondly, add terms
To the polynomial
using user input. So here, she was just calling not like normal getter function.
yes. We call the input.
Yeah, I think this calling
The input function. I mean, P dot input.
inputs. Inputs. Okay. Yeah.
Input. Okay. So after that,
This is 3A. Just these two.
okay. What's
3B.
so print the degree of the polynomial onto the screen. Okay, let's how it.
Print the degree, but here I don't think it's in the
I don't see
running.
this. Yes.
So what do you think? So shall we just stick with the output, or
Oh yes, because this is the expected result. I don't think you should have done anything.
skip 3B?
Okay, evaluate the polynomial with different values of x from 0 to x. Okay. So, see out, I think it's given.
Oh, it is in law. Oh, yeah.
Yes.
So yeah, because the outputs previously should be inclining, and then
Yes, for this here.
like here,
This
x polynomial value.
Yes. Okay, so
That makes sense.
mm,
Now here it's given for x equal to 0, x is less than or equal to 5, x plus. Say out x like
they said they evaluate, right? I think
yeah, call evaluate.
I think you just say evaluate. E dot evaluate, right?
Yeah, b dot evaluate, and
Yeah.
then inside a we have terms is composition, and then we can call the evaluate. Inside there some all the evaluates the all terms and the combine evaluate. So I think it's just now.
Right. Okay.
And then say out it's in both. Okay. So this all this 3C.
Okay.
Let's see. This one.
Okay.
So sorry, run or let's check. Oh, this is all no need.
Constructor.
Previously, do you write the constructor above? Just go above to see.
I think it, yes, I think we should take this because it's given. So we just. So I don't think we need the rest of this because we already defined
Yeah.
the upside. Okay. This is also. Yeah.
I think the constructor above is not there. Don't copy it.
Copy this. Last
Oh yeah. Didn't copy it. Wow.
Okay. You should add semicolon here or no?
Yeah.
Okay. Do you think anything else? I think we should run it.
You can run and find out. So we did it.
Compile and run. I think we should
Sorry.
for
It's no, I'll make it big, small pigs.
That's one. Okay.
Safe. Except. Oh, so it's run.
So I think we should compare it to this. Okay. So for the first output, one,
Let me write the first running screen.
one,
Okay, one term. The coefficient 3x squared, and the next
one, two,
one,
one,
one.
three,
3 is the coefficient.
two. Okay.
0, 3, 12, 27, 48, 75. Oh yeah.
The same. Okay. Try the other second output.
Still to left.
Close this. Okay. Okay. The second output. Yeah. Execute. Okay. Two
Terms,
terms.
x minus 10. First x one coefficient and one except
One.
one. The second is minus 10 is negative 10 and 0.
Negative 10, 0.
Let's check the output again. Yeah, I think. Same.
Yes.
I think same.
Okay, check the third output.
Let me check.
I think it's not a problem.
4 terms.
Okay.
4 terms.
Here, 4 times, right? Okay. 4.
What's the expression? 5. Negative 5x squared plus x cubed.
Negative 5 and 2.
x cube 1 and 3.
1 and 3, 1 and 0, and minus 7 and 1. Okay,
Minus 5, minus 25, minus 38. Check.
yes, it's the same. I don't think there is anything else.
So, what do you think about, maybe if we can get back to our question before? Yeah. What do you think about?
I think it's here. It's this was the question. Can we make the array in the private?
Yeah, the array in the private. Let's check. If we make it in a private, to make any difference, I don't think it will.
Okay. I think we should do it ourselves. Okay. Execute.
Oh, close this.
Ah,
Should work fine. Okay, try.
like the first one. Plus 3 and 2. Ah, yes, it's the same. Okay, I think that's all.
That's all about exercise
Four.
4, and everything is good. So,
I think nothing to edit. Okay.
that's it. Thank you. Assalamu alaikum. Just start sharing the screen.
Uh,
Still recording.